test. Okay, there we go. Things should be working properly now. All right. So we've got these causal arguments. We're going to need to develop some terminology a little bit to make it really clear what we mean by some of the criteria I'm going to give you for evaluating these arguments. So when I talk about the proposed cause, what I mean by that is the causal explanation that's given in the conclusion of the argument. So every causal argument, the conclusion of the causal argument is going to say why something happened. Right? So if I'm saying, hey, I got sick last night because I had food poisoning from eating undercooked chili, the proposed cause in that argument is the eating of the undercooked chili. That's the cause that's supposed to explain the effect why I got sick last night. We're also going to talk about other hypothetical causes besides the proposed ones. These might not even be explicitly stated in the argument themselves necessarily. You might have to go beyond the argument a little bit, just like you had to do in the analogical arguments. But the other hypothetical causes are other possible things that could have explained the effect besides the one that was actually proposed by the argument. So again, what are other possible reasons I could have gotten sick besides food poisoning from undercooked chili? Maybe someone tried to poison me. Maybe I was punched really hard in the stomach. Maybe I have stomach cancer. These are other hypothetical causes, other things that could have explained the event, but the one that's actually posited by the argument, we're going to call the proposed cause. A good causal argument, and this is mostly what we talked about last class period. A good causal argument is one where the proposed cause is what we're going to call the best available explanation, where the proposed cause fits the data better than just any other hypothetical cause. And that's what all of the criteria I'm going to give you are going to be intended to help us determine. Basically, I'm going to give you a list of 5 criteria. You should go down the list in order. It's going to be sort of a sequential list. And each one, each clarification, each sort of step is going to eliminate some of the hypothetical causes, suggest that they're implausible or that other causes fit the data better, or that they're merely correlates, that they're not actually causes. And then at the end, if we have a good causal argument, when you're all done going through all 5 of the criteria, you should end up with just one causal explanation left, and it's the one that's actually proposed as the conclusion of the argument. So that's predominantly what we're going to talk about today, is those criteria. Any questions about anything before we get started? Anything from last class people would like to get clarified? All right, excellent. And again, I'm going to be on that whiteboard a fair amount today. I won't see it if you put your hand up, but if you write something in the group chat, that actually does send me a notification, so I can find that if there's something you would like me to clarify while I'm writing stuff up. All right, so let's get started with these criteria. I just want to emphasize this is a sequential list. So my recommendation to how to approach these problems, start with the first criteria and then work your way down. If at the end what the conclusion says is the cause is the last one left, once you go all the way down the list, you've got a good causal argument. All right, so start with the first one. The proposed cause needs to be correlated with the effect. So let's talk about this idea of correlation. Events are correlated if they go together. So here would be an example. Oh, and there's 2 different ways. You can either always go together, or this would also work if it's just there's a tendency for them to go together. Right. So here are 2 events that are correlated. Here would be an example of a correlated events. Smoking and lung cancer. Why is it? What was the first step in scientists discovering a causal link between smoking and lung cancer? Scientists looked at a lot of medical data. They were looking at who are the people who tend to get lung cancer. And, you know, were more men than women likely to get lung cancer? No, about the same number of men got lung cancer, and the same as the same number of women who got lung cancer. Could it be racial lines? No, basically the same racial demographics. They all got lung cancer at roughly comparative rates. But hey, here's a weird thing: people who smoke, they're way more likely to get lung cancer than anyone else. This would be a correlation. The two things go together. Smoking tends to go together with getting lung cancer. This doesn't necessarily entail that these are causally related yet. That just correlation isn't enough, but it's sort of a first step. So when you're looking for correlations, there's a couple different kinds of correlation. There are what are called positive correlations. This is when increasing the rate of one increases the rate of the other. And the example I just gave would be an example of a positive correlation. The more people smoked, so you increase the rate of people smoking, the more people got lung cancer. Right? They increased one, you increase the other. There's also what's called negative correlation, same basic idea. Decrease the rate in one, decrease the rate in the other. And again, that also holds with smoking and lung cancer, right? When people stop smoking, people who quit smoking, they still got lung cancer at a higher rate than the general population, but people who smoked less got lung cancer at a lower rate. Ideally, these two things would go together. Ideally, the positive correlation would go together. Ideally, you'd see both. That would suggest an even stronger correlation. Now, correlation is not the same thing as causation. Lots of things are correlated without actually being caused. However, all causal relationships are correlations. And let me give you an example that will show how these things can be different, right? In the case of smoking and lung cancer, there is both a correlation and a causal connection. But here's an example where there actually isn't. So in the 1800s, there was a cholera outbreak in England. And what cholera, it's this disease that we now would say what this disease caused by, it's caused by a particular bacteria. But in the 1800s, this was before you actually had any kind of bacterial understanding of disease, right? So this would be prior to people could give that kind of explanation. But what medical doctors started to realize, this was happening in London, they discovered a weird correlation. They discovered that the closer you lived to the Thames River in London, the more likely you were to get cholera. And indeed, they looked a little bit closer. They saw that it is actually even more so if you got your water out of the Thames, if that's your drinking water, if it came out of the Thames River, you were way more likely to get cholera than people who got their water from some other source, maybe from a well water or something of that sort. And so this actually led those scientists to suspect that maybe there's some kind of causal connection between drinking the water out of the Thames River and getting cholera. And what they actually ultimately concluded, mistakenly, it turns out, was that, this is a little bit gross, so I'm sorry, where people would do their business was in the Thames. So the Thames was basically filled with poop. And so they concluded that what causes cholera? Poop. Poop causes cholera. If you drink poop, you're more likely to get cholera than not. Why? Because there was a correlation of drinking the, frankly, poopy water and getting cholera. However, it turns out that is actually not a correct causal explanation. Right? There is indeed a correlation. The two things tend to go together. Drinking poopy water and getting cholera indeed goes together, but it's not the poop itself that caused the cholera, nor is it the water that caused the cholera. It was a bacteria within the water that caused it. So here we have an example of things that are being correlated, the poopy water and getting cholera, but they're not causally related. There's no causal connection. In fact, the causal connection, the actual bacteria that causes cholera, explains why there's a correlation between those two events. So the first thing you need to do, the first of these criteria, You need to check and make sure that the causal events are in fact correlated, but you can't stop here. Lots of events are correlated without being actually causally related. So this is sort of just the very first criteria. If the proposed cause isn't actually correlated with the effect, you don't have a causal relationship. So this is the first way that we can sort of use to get rid of some of the hypothetical causes. If the things aren't actually correlated, you can get rid of any of those hypotheses. You can reject all of those. All right. How are we doing with correlation? Does anyone have any questions, thoughts, comments about how correlation is working? All right, good. Let's go on then to the second criteria. And again, if you do have a question, I can't see it on the whiteboard, but send it through the chat and it'll send a little notification to me. All right. Our second criteria is similar. We're just trying to eliminate some of the sort of obviously bad causal candidates. So here's our second criteria. The cause has to come before the effect. If I'm trying to figure out why I threw up last night, and I said, oh, I threw up last night because of what I ate this morning, my suspicion is that you would all immediately say, no, that's not how causation works. And indeed, you'd be right. Right? The cause has to actually be prior to the effect in time. But there's a warning we have to make here. Again, you can't stop here. If an argument does in fact stop here, if an argument infers that one event caused another merely because that event came before the other, that's committing what we're going to call the post hoc fallacy. So this is a new fallacy. And there's all kinds of things. This is post hoc fallacy is where a lot of superstitions come from, for example, right? Like, oh, I saw a black cat right before I fell down a manhole. Or, oh, I walked underneath that ladder right before I lost my job. And therefore drawing a causal relationship as a result of what's merely a temporal relationship. And a causal relationship needs to be way more than a temporal relationship. If you've got an event that comes after the effect, you know it's not the cause. So you can cross off, this is just another way to cross more stuff off. You can cross off any hypothesized causes that come after the effect. But again, you can't stop there. We're just still eliminating certain sort of obvious bad candidates. Again, any questions with the second criteria or the post hoc fallacy? Most arguments that commit the post hoc fallacy, so like one example you're going to get on the group work, you're going to be asked to explain why something is committing the post hoc fallacy. Anything that commits the post hoc fallacy, there's going to be usually something kind of goofy about the kind of causal connection that's being drawn. It's going to sort of challenge or seem like that's just not even the right kind of candidate to explain why a bad event happened to you or why some event happened to you, right? It just should strike all of us as kind of weird to even think to connect seeing a black cat and losing my job. But those events don't seem like the right thing, kind of thing that should be causally connected. Last time we were calling this the sort of underlying causal framework that we rely on in these kinds of judgments. And indeed, that's the case. With the post hoc fallacy, almost always the mistake that's going to be made is drawing sort of almost just the wrong kind of thing as a causal candidate. And a big part of the reason why is the third criteria. There's a question in the chat. Can you explain what you mean or give an example about what you mean of that last bullet point? So I'm assuming you mean you have an event that comes after the cause, you know it isn't the cause. So sure, let me give you an example of this. If I ate sausage for breakfast this morning, that can't possibly explain why I got sick last night. The temporal order is wrong. The thing that needed to be explained was the me getting sick. That happened last night. Me eating the sausage this morning, that's too late. That can't be it. So I hope that example was helpful. Yeah, I hope that sort of clears up what I mean. Right? But just because something came before doesn't prove it, right? Here's another example. If I don't know, I'm trying to go. If I saw a really funny TV show last night, before I got sick, that doesn't mean, in fact, that watching that TV show necessarily got me sick. So I hope those examples are helpful. I hope they sort of clear up the relationship that I was looking for. And again, yeah, send me more chat notices if you want me to explain something more or want some more examples. That's the perfect way to sort of get my attention when we're doing whiteboard stuff. Just want to check in again. Any other questions or anything else people want to go over with this second criteria? All right, good. Let's go to the third one, the third of these criteria. The third one is the last one. Basically, these first three are all supposed to just be getting rid of sort of obviously bad hypothetical causes. The third one is that the causal explanation that's being proposed should, in fact, fit within the sort of overall causal framework that I use to understand, or to be, in other words, a credible cause. Let's give some examples of this, and let's try to make this last point clear. This one's, it's sort of obvious in a lot of ways. You'll almost, with things that violate this third criteria, you'll almost always know that something is wrong, but you almost won't be exactly clear how to almost even explain what it is that's wrong. It'll just seem like it's obviously not the right cause. So let's give an example first before I try to sort of go into more detail with it. So here would be an example of something that violates this condition. Right? And let's use this past example. Watching funny TV shows just isn't the right kind of thing to cause stomach aches. It just doesn't, those two things just don't go together in a causal way. How do we know that? I don't know. It's sort of hard to explain, right? But we all do kind of just know that those things don't go together in that way, right? And if you really dove into it, tried to come up with an explanation, you can maybe say because of pre-existing scientific frameworks, maybe. Right? Or I know it in some other way. I just know it from experience. But in some, just for some way, there seems to be some obvious disconnect between this kind of thing. Whereas, again, let me give you an example where it works. Watching a funny TV show could explain why someone's laughing right now. Those two events, they do seem to go together. They seem to be plausible that there could be some kind of causal connection between those two things. And again, why? I know this from experience, maybe. For this example, could you say that these two events aren't even correlated? I mean, they were, strictly speaking, correlated. So assuming you're talking about this example, they are, strictly speaking, correlated, I suppose, right? Like, I mean, if you narrow it down, because we're talking about one event, we're not making a general causal claim in this particular case. We're talking about this one specific instance, or this case up here. This specific instance. I watched this one specific TV show, then I got sick. That is a correlation. They went together, at least in this one instance. In general, though, yeah, they don't go together. So maybe you could say that in general they're not correlated, and so that would be maybe another reason you could give for why in general they're not even really a plausible candidate to be causally connected. So yeah, I hope that that's helpful, and hope that maybe that also helps clarify a little bit what I mean by correlation too. Hopefully, excellent. So the sort of background here, right? We always form causal judgments using these pre-existing causal frameworks. We rely on, we talked about this in the last class, right? It's frequently even hard to say where these causal frameworks come from, why we have them, but we do have them, and they give us some vague idea, right? Like last time I was talking about like why light bulbs burn out, and we all just like, we're not primed to think of ghosts. We're gonna check the circuit breaker way before we start looking for ghosts and calling an exorcist, right? That's a result of us having this sort of pre-existing causal framework, some sort of pre-existing idea, even one maybe we don't know why we have it, of what kind of events causes other events. As a general rule, at least in terms of the framework that we're developing here, causal arguments themselves are not going to challenge the pre-existing causal frameworks. That's a different kind of argument. That's what we're going to call extraordinary arguments, or arguments that take recourse to the extraordinary. Someone who genuinely wants to claim, no, I know it sounds ridiculous. I know it doesn't seem like watching TV shows can make you sick, but actually, surprisingly, shockingly, I've discovered evidence that that's true, so we need to throw our pre-existing causal framework out and start over. That's just a different kind of argument. The kind of when we're talking about causal arguments in this sense, we're always going to be working within these pre-existing causal frameworks rather than challenging them. There'll be things that we'll have to say about how you could challenge a pre-existing causal framework. We'll hopefully have time to do that a little bit at the end of the semester. So for all of these causal arguments that we're going to look at, we're just going to presuppose the pre-existing framework. So this should get rid of all almost just silly hypothetical causes. And that's why you sort of want to go in order. The result of 1 through 3, after these 3 criteria, you should basically only have plausible hypothetical causes left. Those should be the only ones that remain after 1 through 3. I hate that these text boxes have a character limit. Okay. So these first 3, they're mainly getting rid of irrelevancies. They're getting rid of sort of ones that, in a sense, you should almost just have this sort of intuitive sense that something's pretty obviously wrong in all of these cases. The remaining 2 are going to be then, now that you've got a really good, plausible set of hypothetical causes, how do I decide which of these plausible hypothetical causes is the best? So we've gotten rid of sort of the silly ones. Now we have to figure out how can we resolve the plausible ones, the ones that we have reason to think could, in fact, be good choices. So any questions with any of these first 3? All right, excellent. Then let's turn to the last 2. So this is now we're at number 4. We now have strong, good candidates. So of the ones that are left, the proposed cause should fit the data as well or better than all of the other hypothetical causes. And this could mean a lot of different things depending on the kind of causal explanation you're looking for, right? If you're doing scientific research, this could be really specific data points, right? You're like, I've got these 10 data points, and this one cause explains 8 of my data points, but this other hypothetical cause explains all 10. Well, the one that explains all 10 is better than the one that only explained the 8. In terms of more everyday kinds of scenarios, right? Let's say I threw up last night. I was sick last night. What are some plausible candidates? Maybe food poisoning is a plausible candidate. Maybe stomach cancer is a plausible candidate that could indeed cause throwing up. Maybe getting poisoned is a plausible candidate. Maybe getting punched in the stomach is a plausible candidate, right? Okay, well, what fits the data the best? Well, okay, I didn't get punched in the stomach last night, so that one doesn't fit the data particularly well. No, as far as I know, no one broke into my house and poisoned me, so that doesn't fit the data particularly well. I don't think I have stomach cancer. That doesn't seem to fit the data particularly well. What seems to fit the data the best then? I did eat that undercooked chili last night. That maybe could have given me food poisoning. That seems to be the one that fits the data the best. So that would be then the one I should propose as my cause. I got food poisoning because I ate the undercooked chili. So someone wants me to back up a little bit to number 3. Absolutely, I can do that. That's why I don't delete them right away. All right, so yeah, hope that is helpful. All right. There's 2 ways that this can end up working out. In many cases, only one of the hypothetical causes will actually fit the data. In other words, you'll have a clear best candidate. But in other cases, I think before we go to the other cases, when this happens, when you have a clear best candidate, you just stop at number 4. Right? Number 4 would be enough. Number 5 is only going to be if you have multiple candidates. Indeed, that can happen sometimes too. In other cases, you'll have a few hypothetical causes that fit the data equally well. When that happens, that's when you go to number 5. Right, and there was a chat question. Oh yeah, perfect. Yeah, that wasn't actually a question. It's a good. Glad that helped. All right. So any questions with number 4 before we move on to the 5th one? This 4th condition, it's a little bit hard to actually describe in the abstract. It's something that you sort of have to see in practice a little bit and do in practice. And you, in fact, do this in practice all the time. You just sort of determine, okay, what actually fits the data that I have available to me, the information that I know, what just fits that information the best. So when we look at more specific cases, maybe you're doing a group work, I think like this will come up in a couple different of the group work assignments. Maybe this would be a great opportunity to call me in if you got questions about how to specifically apply this criteria. But usually it's relatively intuitive. Unless you're dealing with like really specific detailed scientific cases or whatnot, you use this kind of reasoning all the time. You might just not have ever thought about it in precisely this format before. And hopefully, people are good with 3 now, so I can move 3 a little bit out of the way. But I can bring it back if that would still be helpful to anyone. All right, so let's talk about the last of these, the 5th one. This is called Occam's razor. You may have heard of this term before. Right. Occam, William of Occam, technically, was a philosopher from the Middle Ages. You might have also seen this spelled Occam, and yeah, it also is spelled that way too. And what he's most well known for is what's called this Occam's razor. It wasn't an idea that he invented, but he sort of codifies it and uses it really strictly to reach certain kinds of philosophical conclusions. So that's why this sort of principle gets associated with him. Occam's razor basically asserts that other things being equal, and that's really important, this other things being equal part, but other things being equal, simpler explanations are preferable to more complicated explanations. Right? And this other things being equal condition is really important, right? What do I basically mean by other things being equal? I mean, you did the fourth criteria. You actually looked, you found, you tried to cross things off. You only have hypotheses left that all fit the data equally well. Then choose the simplest of the explanations available to you. And so therefore the proposed cause, if it's a good argument, should be the simplest if I have multiple that fit the data available to me equally well. Okay, so let's talk a little bit about what we mean by simplest, because this is again, this is leaving the realm of logic a little bit and getting into some sort of philosophical terrain. But this is indeed not at all necessarily an easy question to answer what we mean by the simplest explanation. So what Occam himself meant, and we'll mean something like this. By simple, we mean it involves the fewest steps. Or to put that slightly differently, or relies on the least number of assumptions. So let me give you some examples of this that will perhaps help clarify. All right. So let's say I'm trying to explain why my computer is not working. Actually, let's even do the same example. I'm trying to explain why did I get sick last night. Two explanations, let's say, fit the data equally well. So one, I got sick because of food poisoning. Two, I got sick because someone poisoned my food. And let's just say, for the sake of argument, say that both of these explanations fit equally well, right? They both sort of fit the facts, they fit the data, they fit the evidence equally. They're both possible, right? Which one should I choose? Which one makes the most sense? And my guess is all of you sort of are thinking like, well, the one you should pick is number one. Why? Why should I pick number one over number two? You're right, I agree, I should pick number one, but why? What is it? Well, it's because number one is simpler. Number two requires people to have broken into my house without me knowing about it and putting poison in my food. It makes more assumptions. It's certainly possible someone could have broken into my house and poisoned my food. And indeed, if I discover evidence of that, maybe I'll change my causal conclusion, right? Because then number two actually would fit the data better. If I discovered evidence that my house was broken into last night, and that someone was messing around with my cupboard, yeah, then all of a sudden that changes the situation. Now, actually, this would fit the data better than everything else. But so long as these two fit the data equally well, there's a lot more assumptions. It's a lot more complicated for someone to have broken into my house and poisoned my food rather than just I undercooked the meat. Right? That's just less assumptions than the assumption that someone was able to break into my house, do it without me knowing it, and then add poison to my food for some crazy, insane reason. Again, not impossible. This is indeed a plausible cause. This is the kind of thing that could make me sick. Important, we have to distinguish 3 from 5. Someone breaking into my house and poisoning me indeed is the kind of thing that could make me sick, so it doesn't violate the 3rd condition. But it violates the 5th condition. There's a simpler explanation available to me that fits the data equally well. So I hope, was that example helpful? Does anyone have any questions with this idea of Occam's razor with the simplest explanation? This is another example of a time when you sort of know it when you see it a little bit. You usually have some vague intuitive sense that, yeah, that seems to involve more steps or be more complicated. I'm getting a chat question. Is it possible that a hypothetical cause could violate one of the first 3, but satisfy the 4th and 5th condition? Not unless it's actually doing that challenging of the underlying causal framework itself. So not in the kind of causal arguments that we're going to be looking at here. It would have to be something that was sort of trying to overturn the whole system of science or something in order to do that, and that's not the kind of causal argument we're going to be looking at. So for this kind of problem anyway, you'll never have an argument that satisfies 4 and 5, but also violates 3. And that's sort of why you do 3 first. 3 sort of cuts out all of the implausible causes so that you're only left with the ones that are superficially plausible. But in principle, sure, there's nothing in principle possible with, maybe some specific case, maybe, walking in front of the black cat corresponding with me losing my job really well. It's just that's not the sort of thing that could ever be a cause in the first place. So it's a bad answer for other reasons, not besides fitting the data or being simpler versus complex. There's other things that have already led me to get rid of that as sort of a plausible candidate. So I hope that answers that question. It's a very good question. And if you want to follow it up, please do so. I want to say just a little bit more about simplicity, and then I'll send you a very little bit more about simplicity. We're running a little low on time. I want you to at least talk with your groups for a little bit today, because you had to listen to me just go on for a long time. So one last little thing about simplicity, right? This can be, in fact, quite difficult to determine in some cases. What is simpler, actually? What is actually the simpler explanation? God created the world. Or the Big Bang. And make it not just the world, God created the universe, so they're actually directly correlated events. Which of these is actually a simpler explanation? I really don't actually know. It's actually really hard to say. And you could kind of come to either conclusion in a sense. I mean, on the one hand, there's a lot of metaphysical assumptions that go into an idea of God. So you need the idea of a perfect being. You need the idea of something transcendent of the universe. You need the idea of an atemporal thing. So there are a lot of assumptions that go along with the idea of God. But on the other hand, if any of you actually tried to read the math behind the Big Bang Theory, it's not like that's simple or easy to follow too. And it too involves many assumptions, maybe quite reasonable and good assumptions, but it too involves many assumptions. Right? So this is a sort of a classic example that people point to when they're actually going through Occam's razor of a scenario where it could actually be quite difficult to actually determine what the simplest case is. In the kind of scenarios that I'm going to give you, you're not going to run into it. It'll always be something, what I give you is going to be very much more of this sort, where it shouldn't be incredibly difficult to determine what the actual simpler explanation is. Again, there should be a kind of intuitive obviousness to it. Now you just have a sort of language that you can use to explain it. One last thing before we go, there's one other fallacy I want to introduce before we do very little group work. Maybe just try to work on the first one today. The last fallacy I want to talk about, in addition to the post hoc fallacy, let's talk about what's called the questionable cause fallacy. Basically, all the questionable cause fallacy is an argument that violates one of these 5 conditions, but does so sort of obviously. And the fallacy, this is similar to the bad analogy fallacy that we talked about with the last unit. The fallacy is really only supposed to apply in the sort of obvious case, the case where it's just sort of obvious that that one of the 5 criteria has been violated in some way. If it's a more subtle thing or a more nuanced mistake, that's not supposed to be an example of the fallacy. We're not going to super worry about that distinction, just like we didn't really worry about it with the analogies either. So this is the last of the sort of fallacies that the book gives us. All right. So I think I'd like you to, again, not just have to listen to me this whole day. So I think I will send you into your groups. Just work on that first question. Then the first question is only looking at, I believe, I want to make sure I'm getting this right because I didn't actually have time to print it out this morning, but I think it's just looking at the post hoc fallacy. Yeah, perfect. So the first question is just asking you to explain why a particular argument commits the post hoc fallacy. So why don't you go through that with your groups? Let me finish creating groups for everyone because a few people came in a little bit later today. Oh, actually enough people that okay. You know what? Actually, never mind. We're not gonna have enough time for this. Enough people came in later that it's probably gonna take me a couple minutes to get everyone put into their group, and we probably just won't have enough time then. So instead of what I just said, cancel, change what I just said. We'll just do nothing but group work next class period. So we'll just come in, I'll put you right into your groups to try to get here right on time for the next class period. We can go do any sort of review anyone wants to do. Otherwise, I'll just have you go through these causal arguments, and then I'll, so class is dismissed. One a little bit early today just for time reasons. For anyone who would like it, here is the last thing that was on the whiteboard. Otherwise, class is dismissed. I'll see you all on Friday, and we'll just do all of the group activities on Friday. Yeah, we didn't have enough time to start today. You won't have to at least listen to me ramble on all day on Friday, at least. I can promise you that. Have a good one, and I will talk to you all later. And I hope that was enough time on the whiteboard. I can bring it back up if anyone still wants it. I just want to cancel the recording first.